Hey guys, good morning. I was looking over some stuff again today and try to keep this short, but here is the picture of the Earth, the Sun, and these are the Lagrange points. 1, 2, 3, 4, 5, which are fixed orbiting positions for satellites to be parked, where they'll stay in the same spot relative to this picture 24/7. And this is where the ACE satellite's parked at the L1 position. Okay, L1 Lagrange point, located between the Sun and the Earth. It's approximately 1.5 million kilometers away from our planet. So that is, take 0.62 times 1.5 million, it leaves you with 930,000 miles. So that's where it's parked. 930,000 miles out here. So all the data you're getting is coming from the Sun to this 930,000 mile mark. So here's the latest run on the ACE real time. You can look 2 hours, 6 hours, 24, 3 days, or 7 days. I got it on the 24 hours. Then if you pop it on there, you get a full screen view. And what I wanted to focus on were two things. First, we'll go look at the solar wind speed. As you can see, this is a run that started around the 1300 hour mark of yesterday, and the solar wind speed was up around 400, and then it's been steadily declining. Then we still have this gap here, 7-hour gap from 2300 hours to like 0600 hours. And I looked online yesterday and I could not find any explanation for this gap. In fact, I looked at some archive data, which wasn't actually showing a chart, but it showed data that was data streamed for the whole, looked like 24 hours, but I'm not positive on that one. But anyway, that's not exactly the point I want to make, but it is still something that's in my mind and I'm trying to figure out. So, okay, here we go. We got the ACE satellite. It's 930,000 miles from the Earth. This is picking up all the data coming from the Sun. Solar wind density, the phi angle. This is some kind of magnetic components that I'm not exactly well versed enough to figure out. And then here's the temperature. Quite a fluctuation there. There's what I wanted to show you. So you can see the solar wind speed steadily dropping, right? And it looks like it continued to drop through that missing 7-hour period all the way down to, I mean, it almost doesn't register. It's a little above 300 kilometers per second. That's a very low solar wind speed. So here's what I want to show you. Now I only pulled up a couple here, so we're going to look at this. This is the Z cut. It shows you the solar wind velocity. And this is from the satellites that are in geosynchronous orbit around the planet at the 22,236 mile mark. You see it on the magnetopause. I didn't pull up the magnetopause for this demonstration. As a matter of fact, the magnetopause kind of quit running at 02:00.25 hours for some reason. It stopped. We're not getting anything out here, none of this data. But anyway, look at this solar wind speed. Look how much it's fluctuating. You saw how it was up around 400 yesterday. So let's go back to, here's the earliest I have it from yesterday. So there's 119. 0119, we got the solar wind speed yesterday at 1900 hours, 389. Now watch how it fluctuates. It's all over the place. And as you can see from that ACE chart, all the data coming from the sun was all pretty smooth. And in fact, it was steadily declining. Look, it jumped all the way up to 700 something there. So this is what has to be happening. There has to be something in here, or something in here, or something in here that's between the ACE satellite and Earth, which is 930,000 miles away, the ACE satellite, in order to cause this solar wind speed to jump and not be registered by the ACE satellite. You get what I'm saying? You can see it's all over the board. I mean, crazy stuff there. There it is, back up to 6 something. This was on 0800 hours today. 0800 hours today. Solar wind speed was around 320. So, you know, that's got to be another solar body. So if you can picture this, here's Earth, there's the ACE satellite, 930,000 miles out, parked out there between the Earth and the Sun. Then there's the Sun, which is like 93 million miles from Earth. Now, this Nemesis binary twin is supposed to be maybe 4 to 5 times the mass of Jupiter. Jupiter's a gas giant, so its radius is quite large, mostly hydrogen and helium, but its mass is only 1/1000th that of the Sun. So if you take 4 to 5 times that, which would be like, say, maybe 5,000th mass of the Sun for this Nemesis binary twin, which would make it considerably smaller, and therefore its solar system would be considerably tighter. So I'd say it's quite conceivable that somehow it has slipped in close or somewhere off to the side where it's buffeting the Earth with its solar wind, or it's gotten past the ACE satellite range and it's within 930,000 miles or less of the Earth. Either that or it's off to the side somewhere, and it could be even out here. Maybe the solar wind's coming around in these magnetic field lines, because as I showed you yesterday, all these interplanetary magnetic field lines, which you can see are all over the place. They're only supposed to be represent a magnetic field direct connect from the Sun to each one of the 9 planets. And since we only have 9 planets, and say Nemesis has 7, so that would be a total of 32 connections if you connect the Nemesis with all of our 9 known planets, and connect Nemesis with its 7, and then our Sun connect into all the same. That would be like 32 interplanetary magnetic connections. But anyway, getting back to Nemesis being somehow inside the ACE satellite, 930,000 miles. Now, if it's only 0.0000005, 2 zeros and a 5, the mass of the Sun, it could easily, I would say, have slipped in that close. Otherwise, or it could be out here somewhere, and the ACE satellite's only reading data that's coming in like directly from right in front of it. I don't know what kind of a radius it has on its data collection devices from the sun, I would imagine it's not just straight linear. So that leads me to conclude more as I'm thinking about it that Nemesis might well be within inside the 930,000 mile mark between a satellite and the sun. So here we got all these, and these other magnetic field lines would suggest the same. So picture the Nemesis sun out here somewhere, or somewhere in between here and Ace. Say this is Ace out here. Then we get these field lines cropping up. Well, they can't be coming from the sun, so this would be maybe Nemesis connecting with either some of our planets or some of its planets. But anyway, I thought that was interesting. So one other thing I wanted to show you, and we'll explain it down here, and I'll put the links below again, of course. The phi angle. Got a direct connect now. Starting around 0600, it started to climb. The connection is, remember that I'm going to show you again on that explanation that at 180 degree mark, that reflects a direct connect between the sun to the earth. 0 would be from the direct connect from the earth to the sun, which I don't think happens all that often. I mentioned yesterday, since the sun's so much more powerful, it would be the one that would be making the connection, I would think. So anything beyond 180 would reflect some kind of a connect with a solar body behind the earth. And as you can see, starting around the 0600 hour, and by 0800, we're pretty firmly connected to Nemesis, or something behind the sun, or electromagnetic field lines. So maybe Nemesis could even in fact still be out here somewhere, but one of its field lines could have wrapped around and made that connection. You get what I mean? So that happened around 08. So we'll play these out. They're rows pretty much synced. This is what happened around the time when we made that direct connect with something behind the sun, or behind the earth rather. So anyway, here's the tutorial. So there's, once again, this explains the phi angle, what I've been telling you. So to recap, and I'll put the links below, solar wind speeds dropping last 24 hours. The ACE satellite is way out here. It's reading the data from the sun just up into the ACE satellite. Nothing between the ACE satellite and Earth. That gets read by, well, there's the moon, but that gets read by the satellites that orbit the Earth, the GOES 13 and 14 and whatnot, at around 22,236 miles. That's the data we're getting for all this stuff, is my understanding anyway. So you can see the solar wind speed, which is being measured between the ACE satellite, well, actually between 22,000 mile mark, 22,236 mile mark in the Earth, is much different than the solar wind speed coming directly from the sun. So that has to mean there's some kind of another solar body that's exerting the solar wind on our planet on the front side. That would be on the light side. I pulled this up just for the heck of it. The Mauna Loa Solar Observatory run from yesterday. Pretty much showing the same thing. We got the circle deals here with looks like could be magnetic field lines maybe coming from them. I would say that might be a couple planets. And but anyway, I'm running out of time. Peace out. Leave your comments down below, and hopefully I can address them.